Welcome back, everyone. Today's lesson is our second lesson on solving quadratic equations. So yesterday we looked at our first method, the factoring method, and today's lesson will look at using the quadratic formula. And we generally use the quadratic formula when we are unable to factor the equation. So the most preferred method actually is to factor, and if you cannot factor, then you'll use the quadratic formula. So let's get started. Lesson 3, solving quadratic equations using the quadratic formula. Solve quadratic equations factoring method. Yesterday we looked at the most common method, which is factoring, for solving quadratic equations. In your own words, explain the steps that we took to solve quadratic equations. So this is a good spot to stop the video and try to write out the steps you need in order to solve using factoring. So number 1, we need to bring all terms to one side, setting the equation equal to 0. Number 2, once we have all the terms on one side, we need to factor the equation. 3, we're going to set each bracket equal to 0 and solve. Remember, when we're solving a quadratic equation, we're just looking for the zeros, which are our x-intercepts when we solve. So let's look at our first exercise here. Solve the following quadratic equations. So let's start with our first step. Remember, you can stop the video. This is from yesterday and try them on your own. So we're going to bring all the terms to one side, setting the equation equal to 0. So I'm going to bring over the 6x, and I'm going to bring over the 9. Remember, as you bring them to the other side, you will change the signs. Step 2, we'll factor the equation. The only factors of 1 are 1s. We'd put x in our first bracket. We know the factors of 9 are 9 and 1 and 3 and 3. Trying the ones closest together. When I do my smiley here, I have 3 and 3. And I need a negative 3, so these would be negative. So to solve this, as you can see, both brackets are the same. So really, I'm just setting negative 3x equal to 0. Or x will be equal to 3. So our solution here is x equal to 3, meaning that this parabola would only touch the x-axis at a value of x equal to 3. The next one, we need to move all the terms to one side. Remember, you're writing it in the form with the squared first, then the m term, and then we'll bring the constant over, changing its sign and equaling to 0. Once again, we have trinomial factoring, so we'll set up our brackets. The only factors of 3 are 1 and 3, so I'll have an m and a 3m. And the only factors of 2 are 1 and 2, so I'll try the 1 here and the 2 here. When I do my smiley here, I'll get 3. And when I do my outside smiley, I have 2. I need to get a negative 1, so I know the 3 has to be negative, so I'd have a negative and a positive. Once again, the next step is to set each bracket equal to 0. And then we just solve. So m is equal to 1. Or m is equal to, we'll bring the 2 over for a negative, and then we're going to divide by 3. So a negative 2/3. The last one, all the terms are on the same side and it's equal to 0. If you don't like the 0 first, you can always write the 0 over here, equal to 0. So if you like that as a starting point, you can always rewrite it so the 0 is at the end. Once again, if we were to look at factoring this, the only factors we have here are x, and the factors here are 1 and 8 or 2 and 4. And if I try 2 and 4 here, when I do my smiley, I have 2 and 4, and there's no way they either add together and give me 6 or they subtract and give me 2. So I know 2 and 4 don't work. My only other option is 1 and 8. When I multiply the outsides together, I get 8, and the inside's 1. If I add, I get 9. If I subtract, I get 7. So this does not factor. And that leads us to today's lesson. We can't always factor a quadratic expression, so therefore we need to have another method in order to solve the quadratic equation. What did you notice about C above? So what do we notice? It does not factor. If you cannot factor a quadratic equation, you will still solve the equation using the quadratic formula. So how do we do this? Solving quadratic equations with the formula. So it's always good to write the formula at the first of each question, just so that you're able to memorize the formula, because it's not a formula we normally give in an evaluation. So when you are asked to solve a quadratic equation, always blank first. So we always want to try to factor first, that is the preferred method, and set each of the factors to 0 to solve for the variable. If you cannot factor the quadratic equation, use the quadratic formula. And this is the quadratic formula. So once again, you probably starting out want to write this out each time you do a question so you're able to memorize the formula. Before you can use the formula, you must recognize your A, B, and C means in the quadratic equation. Once all the terms are brought to one side of the equation. So we're writing this in standard form. It has to be in standard form before you can use the quadratic equation. So you're going to have the squared term, then your x term, your constant equal to 0. So this is the form needed before you can start using this formula. A is always a number attached to the x squared, or the squared value. B is always the number attached to your x value. And C is always the constant term. So if we were to look at this example, our A is equal to -2. B is equal to 3. C is equal to -5. So the first step in each one of these equations is to first get it into standard form and then state your A, B, and C. And we'll do a few examples together to practice that. Find A, B, and C for the following quadratic equations. We're not using the equation here. We just want to set up the equation and identify our A, B, and our C. So the first thing we're going to look for is if it's in that form of standard form. X squared, then my x, then my constant equal to 0. And this one is. So I can just write out what my A is. It's going to be 2. The B will equal -1. And the C will equal 4. If we look at B, though, we do not have all the terms on the same side equal to 0 in the proper order. So I'm going to bring the terms to this side. So first off, I'd have my 7x squared. I'm going to bring a -2 over. Remember, when I bring it over, I'll change the sign. And I'll also bring over the 3, and I'll change the sign, and then it will be equal to 0. Once I have it in this form, I can say my A is 7, my B is equal to 2, and my C is equal to -3. For C, we only have one term on the side, so we have to bring the 13 over. Remember, when we're bringing the 13 over, we'll change the sign, and that will be equal to 0. So I have my x squared term. There's no x term, and then I have my constant. So my A will be equal to 4. B, because there is no x term, is 0, and C is equal to -13. So that's the very first step you need in order to use your quadratic formula. Getting it into the right form and then identifying A, B, and C. So let's try a few examples actually using the formula now that we understand that skill. So what are our steps in using the quadratic formula? Simplify both sides of the equation as much as possible. Bring all terms to one side of the equal sign. The other side must equal to 0, just as we were doing up here. We're going to determine A, B, and C, and then we're going to plug those into the formula. So those are the steps we'll follow here for the next few examples. A. So step 1, both sides of the equation is we're going to simplify. Well, we have this simplified. There's no like terms, and that's just a 0. Bring all terms to the other side, making it equal to 0. Well, we already have step 2 done. Step 3, determine A, B, and C. So remember, this is your A term, so we know A is 1. This is the B, so -5, and this is C, which is -8. Now 4 is plug in A, B, and C to the quadratic formula. And once again, I might not write this out for each example, but you should until you have it memorized, because you don't want to be losing marks on an evaluation just because you haven't memorized your formula. So let's substitute in. Remember, when you substitute, you should substitute into a bracket. So I'm just putting brackets where all these variables are, and I'm going to substitute in my value into those brackets. And this just helps us with our integer signs. So first off, here is B. It's -5. So I know a B goes here, and a B also goes here. I look at my next term. The next thing I see in my formula is A. So here's A. So I can put that in here. And there's also an A down here. And then the last term that I notice that I have to put in is my C. And I can put in a -8. Once you have put it into the formula, we'll just solve this in a few steps. So first off, I have a negative and a negative. So I know I have a +5. And then we'll just do the calculation. You might need a calculator to do this, and you will probably need calculators for doing your quadratic formula. So we have -5 squared, which would be 25. A negative and a negative here is a positive. And I have 4 and 8, which would be 32. So let's just write those two numbers down. I was going to do it all at once, but let's write them in. And then I have 2 times 1 for 2. Let's bring our equation up here. So I'm just going to simplify under the radical sign. If I have 25 and 32, that equals 57 divided by 2. Let's go back to our instructions. Solve each quadratic equation using the formula. Provide both the exact solution and a rounded solution to 3 decimal places. So we also need a rounded solution. So our exact solution is, first we'll take 5. We're going to add root of 57 over 2. Or the other answer would be x is equal 5 subtract 57 divided by 2. These are called exact. This is our exact answers. Now our approximate answers, or our rounding ones, is when we just put the values into the calculator. So we'll have x, use your approximate sign, In your calculator, you'll put 5 add root 57 divided by 2. So you might want to even put this, you can put this in and then hit your enter button, divide by 2, or you can put a bracket around these to get the correct answer. So your choice. And what we get for an answer for our first one here to 3 decimal places is 6.275. Then when we put this one in the calculator, remember you're putting 5, subtract root 57, hit enter, and then divide by 2. And you should get an answer of negative 275. So let's try our next example. Our first step, remember, is to get all the terms on one side equal to 0. So we'll have 2x squared, bring the 3 over for negative 3x, bring 5 over for negative 5 is equal to 0. Since we have it in the correct form, we can identify our A, our B, and our C. And we'll put it into the quadratic formula. For AC all over 2A. Remember, wherever there is a variable, you will be substituting into a bracket just to make sure that you do the integer work correctly. So once again, I need my B. My B is negative 3. I need another B. Minus 4, my A here is 2. And my C is negative 5. Divided by my A, which is 2. We'll bring this equation up here. Is equal to a negative and a negative will be a positive 3. I have 9 when I square my 3. A negative and a negative here is a positive. And I know this multiplies by 10 and this to 4. Let's just write that in. So 9, negative and a negative will be a positive. 4 times 2 is 8. 8 times 5 is 40. Divided by 2 times 2, which is 4. So x is equal to, remember these are the exact solutions, and we can add these together for 49, or x is equal to 3 subtract 49. What is the square root of 49? It's 7, so we know we can simplify that. And then we can simplify the numerator here on both sides. And we could simplify this fraction because we know we can divide it by 2, and we can simplify this to negative 1. So these are the exact answers. It also asks us to provide our rounded answers. So 2 divided by 5 is just 2.5, and this would just be equal to negative 1. Those would be your rounded answers, and then this are the exact answers. Once again, if you're getting the hang of this, you might want to turn off the video and then try one on your own. It's your choice. So let's look at our next example. Once again, we have the x squared, turn the x in the constant. So my A is 5, my B is negative 3, my C is 5. I'm going to try and write a little smaller. I have such big writing that I'm finding it a little bit difficult to keep it all in this space. So once again, wherever there's a variable, you'll be substituting into a bracket. Our B is negative 3. Subtract 4, A is 5. And C is 5. And then on the bottom here, we also need A. So that will be equals, we can simplify this to a 3, add, subtract, 9, and we have 4 times 5 for 20 times 5 is 100. So we have a minus 100 over 2 times 5 is 10. So x is equal to 3 plus or minus the square root of negative 91 all over 10. Now right here, what happens when you put this in your calculator? We can't take the square root of a negative number. This will give you an error in your calculator. So our answer to this question, because we can't calculate this, is there's no real solution. And what does this mean if we have no real solution? Well, one way of looking at it graphically is we know this parabola opens up. So we don't know where the vertex is or whatever. But if it has no solution and opens up, that means it looks something like maybe like this, right? Because we know what we're solving for is the x-intercepts. And this would have no x-intercepts, so it has no real solution. It is a quadratic equation, but it just doesn't have a solution because it's not crossing the x-axis. So let's just create ourselves a little flow chart on how we solve quadratic equations. So if we have our equation, one of the first questions we're going to ask ourselves is, does it factor? So does it factor? No. Yes. If it factors, then we'll just factor the equation, set brackets equal to 0. And we'll solve for the variable. If it doesn't factor, then we're just going to use the quadratic equation. So the first thing you're going to see, does it factor? Yes or no? And then the next thing is which method are you going to use and how do you solve using that method? So once again, if you're feeling confident in this, please try these on your own and then just come back and check in with the video. Solve the following quadratic equations. Remember to check if you can factor first before using the quadratic formula. So let's look to see if we can factor. Well, we only have 2 terms. We know the type of factoring we would try if it was 2 terms is a difference of squares. So let's check to see if this is a difference of squares. Squared number, squared variable, squared number. And they have different signs. So I know this is a difference of squares. I'll create my brackets. Remember, for a difference of squares, it's the square root of the first term, square root of the second term. One will have a negative and one will have a positive. Then we're just going to set each one of these brackets equal to 0. So we'll have x equal to, remember we're going to take the 7 over for a negative 7, and then we'll divide by 4. X is equal, we'll take the 7 over for a positive 7 and divide by 4. So this is the solution. Oops, I forgot I meant to do this over here, and yes, this factored. We can write in the A, B, and C for this. We don't need it because we're not using the quadratic equation, but it's still good practice. So I know my A here would be 16, my B would be 0, and my C is negative 49. Let's try the next one. Can we factor this one? So let's just give it a little try. We can have 3x and x. Those are the only choices, and 3 and x are the only ones for the other one. I know I can't put the 3 here because that would create a common factor, so 1 and 3. When I do this, I get 1x, and when I do this, I get 9x. So if I add these together, I would get 10, and I need a -2. So this does not factor. What is my a? My a is 3, my b is -2, and my c is 3. So I'll plug these values into the quadratic formula. So x is equal to -b plus or minus the square root of b squared minus 4ac divided by 2a. We'll set up our substitution brackets. And then we'll substitute in. Our b is -2. b will come here. -4, a is 3, c is 3, divided by 2a, which is 3. So a negative and a negative will be a +2 plus or minus the square root. I have 4. We'll have a negative here. 4 times 3 is 12, times 3 is 36. Divided by 36. I should have moved that up here maybe. So now I have x is equal to 2 plus or minus 4, and -36 is -32 divided by 6. Once again, if I get a negative here, this would give me an error in my calculator. So my answer here is no real roots. That just means that our parabola does not cross the x-axis. One more example. Once again, we're going to look to see if we can factor this. I notice first off, I only have 2. And I know these aren't squared values, so I know it's not a difference of squares, but I notice they have a common factor of 5 and x. So I'm going to common factor out 5x. Once again, I can set these equal to 0. Sorry, this does factor. Or x add 2 equal to 0. So when I solve this, x is equal to 0 is one solution, x minus 2 is the other solution. And just for practice, we can still write these in even though we're not using the quadratic formula. So my a is 5, my b is 10, and this time my c is 0. So from today's lesson, you should have learned how to solve, well, reviewed a bit solving by factoring, as well as how to use the quadratic formula to solve a quadratic equation if you're unable to factor.